Ladies and gentlemen, 20 years ago, BP scientists asked themselves this question. At a time when the world needs a lot more energy, why is the average oil recovery factor so low?
Although recovery rates vary significantly, the industry average is only 35%. So 65% of the oil is left behind.
For a giant or supergiant field, this could be the equivalent of leaving hundreds of millions of barrels still in the ground.
And the recovery factor equation explains why multiplying four fractions together, all less than 1, results in a small number. For example, 60% displacement times 70% sweep times 90% drainage times 90% cutoff gives an industry average of
34%. Now this led us to take a closer look at what was happening at the molecular level.
And we found something highly significant.
We did.
Maximising oil recovery isn't just a physical process, it's also a chemical process.
The variations within the porous rock, the large contact surfaces, and the differences between oil and water all make achieving high recovery rates very challenging.
And the focus for our enhanced oil recovery programme: how do we displace more oil from rocks at the pore scale and improve reservoir sweep?
Today, BP leads the industry with a broad range of breakthrough EOR technology to maximise recovery, trialled and deployed in the field, whatever the conditions.
At our giant Prudhoe Bay oil field in Alaska, we're on track to achieve a field recovery rate of 60%, thanks to our distinctive designer water EOR and designer gas EOR technologies.
Breakthroughs like these depend on deep capability and sophisticated lab equipment. We've added what we believe to be the world's first automated core flood unit to our research labs in the UK.
This will enable our EOR R&D teams to perform 300 reduced condition core flood tests every year, maximising our ability to test and develop new EOR technologies.
That's 10 times what we can do today. But of course, EOR is only half the equation. Time and again, technologies like these have been proven to deliver most value, and they're considered as part of an integrated solution.
And at BP, unravelling the complexities of a giant field all starts with understanding a hydrocarbon basin in its entirety.
I would liken it to building a complex jigsaw. Our goal is to identify a highly productive, valuable basin, and we do this by integrating data from stratigraphy, from gravity and magnetics, from regional seismic, and from outcrop. And we put all this evidence together, and from that we create key depositional environment maps. And we use these to hone in on where the key plays could be and where the prospects could be inside those plays.
In Iraq, for example, where we're now developing the Rumaila field, we're using the knowledge and information that BP gained when it worked there over 60 years ago. Technology allows us to locate the fields that previously we would never have been able to find.
Looking at a problem from many angles to reach a better solution was also the spark of the most recent wave of land seismic innovation.
Seismic imaging technology can have the biggest impact on our ability to access the prize within a giant field. But acquiring high-quality seismic data efficiently over vast land terrain above giant reservoirs has long been a challenge for the industry.
So at BP, we took a different approach by taking our industry-leading wide azimuth seismic from sea to land. We have revolutionised the quality and speed of 3D data acquisition. 5 miles down, that's a long way.
With independent simultaneous source, or ISS, seismic trucks can operate independently of each other, as any interference between their signals can later be removed with advanced processing. This enables them to cover a much wider area and significantly cut survey time.
In Oman, for example, we've been able to acquire this critical subsurface data in a day, what used to take a week using conventional land seismic.
Leading to faster analysis and better decisions on where and how to drill.
And with our new Centre for High Performance Computing in Houston, able to perform over 2,000 trillion calculations per second, we are pushing the forefront of seismic imaging technology at a rapid pace.
And getting more out of the data we have is also fueling our next phase development for our industry-leading field of the future digital technologies.
And the integration of real-time information holds tremendous promise for giant fields in improving operational efficiency and increasing recovery.
For BP, it's about giving people insights into what's happening or what's about to happen and providing them with information to help them solve problems before they arise and optimise operations. Harnessing the power of systems and tools that provide us with early warning indicators to ensure the safe and reliable drilling of wells. And significantly reducing the number of stuck pipe incidents. And building on our technology leadership to incorporate more powerful sensing and predictive capabilities.
Integrating and implementing solutions right across the entire company.
Driving the automation agenda forward.
Trusting technology and turning insights
into foresight.
Our approach is to work with many technology partners and to apply the right technologies in new surroundings and to solve more challenges. And of course, our top priority is always to operate safely and responsibly. Together, we can ensure that more countries maximize the value of their natural resources for the benefit of their citizens and businesses. And together, we will meet the world's energy needs, pioneering new generations of equipment, new ways of thinking, and new ways of working.
So you see, there's really only one way to maximise recovery from giant fields. Technology, plus expertise, plus partnership. Ladies and gentlemen, with BP, it all adds up. Thank you for listening.
Thank you.